Good afternoon and welcome to Student Learning Objectives for Geometry Teachers, for GET, Geometry for Future Teachers classes. Our presenter today is Nathaniel Miller of University of Northern Colorado. If you have any questions for the presenter during the session, please feel free to enter those into the chat at the bottom of the screen and we will address them at the end of the talk. On that note, I'll hand it over to our presenter.
Hi, everybody. Thanks for being here. I'm Nat Miller from the University of Northern Colorado, and we're talking today about essential student learning outcomes for geometry for teachers courses. So one of the things that's kind of unique about the geometry for teachers courses is that nobody really agrees about what should be in it. Most places that have courses for future secondary teachers have a geometry course, but at different places it's a different thing. And so one way to try to get a handle on what should be in such a course is to try to come up with some kind of minimum of what some group of people think should be in such a course. And so over the last couple of years, I've been leading a working group, and it's a working group made up of mathematicians and math educators from all different kinds of places. And we've been putting together a set of essential student learning objectives for this course. And so I'm going to talk about those a bit today, and then also I'll talk a little bit about the process that we've been going through to kind of come up with those. So the group that's been doing this is called Get a Pencil. It's a faculty online learning community that is dedicated to the improvement of college geometry for teachers courses. That was organized through an NSF grant by the GRIP lab at the University of Michigan. A faculty online learning community is a type of community of practice. So that's a network of peers who engage in similar practices, share common interests, and interact on a regular basis to learn from each other. And a faculty online learning community is one in which faculty meet virtually over an extended period of time. They come from different institutions and they have common pedagogical interests. So that's what Get a Pencil is. And one part of that are these working groups that formed around different problems. They've been led by members of the community who are trying to address different problems that they saw. These groups have been meeting for 1 or 2 times a month for now several years, at least some of them. The working groups are self-selected. They're made up of people who want to be there, mostly who are teaching geometry courses. They are diverse both in where they are and what kind of institution they are, what kind of faculty they are, whether they're mathematicians, whether they're math educators. We kind of have the full gamut of different kinds of people. So the group that I've been working with has focused on writing these essential SLOs. There have been some other groups doing things like focusing on transformational geometry, identifying PCK for teaching geometry, and some other things. So we got together and we wanted to try to come up with these SLOs. And so this is the process that we went through. We started out by having everyone write down what they thought would be, for them, they thought would be reasonable SLOs. And then we put that all together into one giant document. And then we went through it as a group and said, okay, well, yeah, we all agree on this one. No, we don't all agree on this one. Let's take it out, and so on. So we kind of winnowed away at the larger group of ideas. And we came up with 10 SLOs that we all thought were essential. And then with each SLO, we've written some summaries, and we've written narratives to go with them. And typically what's happened is a group of a couple people has written an initial draft of a narrative, and then the whole group discusses the draft, and then it gets revised, and we keep doing that until everyone is mostly happy with the narrative. And so we get all the different viewpoints kind of together there. So just to give you an idea of kind of the range of people who are involved with this is a paper that we submitted to a book in the AMTE professional book series that's currently under review. And it shows the group of authors that contributed to that paper, and that's not in everyone who's been working on this. So you can see it's quite a large group and from all different kinds of places. So here are our SLOs that we've come up with. There are 10 broad categories of SLOs, and then we also have some process objectives. And I should say that these also have been kind of revised over time. So there was an initial group of SLOs, and as we've written the narratives for them, the SLOs themselves have also changed. So here are our 10 SLOs, and I'll go through them each in a little bit more detail in a second. But we have proofs, critiquing reasoning, secondary geometry understanding, axiomatic systems, definitions, technologies, Euclid, constructions, non-Euclidean geometries, and transformations. And then also these process objectives, where we think that all GeT courses should give pre-service teachers many chances to experience and develop proficiency with the mathematical process skills of problem solving, oral and written communication of mathematical ideas, and productive collaboration. And they should also have opportunities to engage with the progression of geometric exploration, followed by conjecturing, and then construction of arguments. So I'll go through these in a little more detail. On each slide for these, what I've put here, it's a little bit hard to read slides as somebody's talking, but the group kind of did a lot of work in writing these one paragraph executive summaries of each of the SLOs. And so that's what I've included here on the slide. So I'm not going to just go through and read them, but proofs are interesting because we always think that as mathematicians, we think, oh, that's what mathematics is about. That's super important in every course. But of course, it's more important in some courses than in other courses. And geometry really is a place where we do expect people to deal with proof, particularly in the secondary curriculum, right? That's one of the main places we talk about proof in the secondary curriculum. So we want to be kind of thoughtful about how we're presenting proofs in our courses for pre-service teachers. So we want to kind of make that very explicit. So in the courses, we might not just be doing proofs, but we might be talking about what makes a good proof. We might be looking at different proofs of the same thing, and so on and so forth. And then related to proofs, but not exactly the same, is this idea of critiquing reasoning. So having somebody present reasoning, and that person might be the teacher, it might be a book, it might be a student, it might be the student critiquing their own reasoning. Those are all different arenas, important arenas in which this happens. But we think that students should have not only opportunities to write proofs and to write their reasoning out, but to evaluate proofs and other kinds of reasoning. That could be they're working in a group and somebody in their group says, oh, I think this is true, and says something, and then they're critiquing it. Or it might be more formal. It might be a written proof. It might be a student presenting at the board. It might be on a take-home final where maybe the teacher gives some kind of proof for students to evaluate in some way. So there are a lot of ways this could happen. But it's really an essential skill for our future teachers. So we want to really emphasize it in the courses, and in this course in particular. Secondary geometry understanding. So that's understanding the ideas underlying the current secondary geometry content standards and use them to inform their own teaching. There are a lot of different things that could be in a secondary geometry course, and we didn't want to have just a big list of, you should understand the Pythagorean theorem and you should understand triangle congruence and so on and so forth. So instead, what we said is you should understand the ideas underlying the current secondary geometry content standards, because those might evolve as time goes on. And they might be different for people, say, in your state, or wherever you are. And so this is encouraging people to look at the national standards, to look at their state standards, and just try to understand, like, what is it that the secondary teachers are going to have to know, and use that to inform your course. Axiomatic systems. So another thing that happens in geometry courses is it's often people's only introduction to axiomatic systems. So the idea of starting with axioms and then proving theorems from them. And then also the related important idea of having different models where the axioms are true and using that to understand what things you can prove from certain axioms. That's something we do in geometry courses that we could do other places, but we usually don't. Or we often don't. So we think it's important that this is covered in the geometry course. And one of the nice things about geometry as a place to do this is that we have a lot of different kind of very natural models that are not just logical models of the axioms, but are actual geometric objects. We can think about geometry in the plane, geometry on the sphere, geometry on the hyperbolic plane. So different kinds of non-Euclidean geometries, which are interesting in their own right, but they're also interesting from the point of view of, this possible consequence is not true in this geometric place. And so it means that you can't prove it from these axioms. Geometry is a great place to talk about that with students. Definitions are, again, something that we think is very important throughout mathematics, but is nice to discuss explicitly in a geometry course, where you can say something, we could say, what is the definition of a square? And then we could have different people come up with different definitions, and we could compare and contrast them. We could look at what you might be able to prove from different definitions. We might look at how different definitions change when we put them on new surfaces. And here it talks about parallel and how proving that two lines are parallel because they don't intersect is different from proving that they're parallel because they're everywhere equidistant. And those two things might give us different kinds of shapes, say if we took it from the plane onto the sphere or into hyperbolic geometry or wherever. Technology, effectively use technologies to explore geometry and develop understanding of geometric relationships. And in particular, dynamic geometry environments are really important. They are they're not that new at this point, but they're relatively new in the sense that they're only, maybe 30 years old, which, considering how old geometry is relatively new. And we think that dynamic geometry environments are really important and nice tools that can be used in these kinds of classes. There is another developing area, which is digital proof tools, which have started to come out as well, that some people are using. But definitely we think that people should be using dynamic geometry environments, such as GeoGebra or Sketchpad or anything like that. Euclid, we would like students to have a chance to talk about Euclid's elements and its effect on math as a discipline. Constructions, we'd like them to be able to carry out basic Euclidean constructions and justify them. And this is really important because this is something that's done a lot in the secondary curriculum, but often in a not very thoughtful way where it's more about, can you just do a construction? And the really nice thing here is that constructions are a beautiful way into proof for students, that being able to explicitly say, oh yeah, you do this step and then this step and then this step, and then here's how we know what you get. It's a really nice place for students to enter into giving proofs. Non-Euclidean geometries. We think that all these courses should expose students at least a little bit to non-Euclidean geometry, so that they can compare with what's happening in Euclidean geometry, and think about why things might be true in different places. And then the last SLO is transformations. Transformations are a larger part of maybe some of the more current sets of standards than in some of the older ones. And so this is one area where people, and sometimes new teachers, are not that comfortable teaching this with their students, but really using transformations to understand congruence and similarity and prove things. We think that should be at least somewhat in every course. And then I mentioned these process objectives, which are things that we think, areas that we think that students should have the opportunity to develop skills in. So then I just wanted to briefly mention at the end here some nice things about how these were developed. A lot of standards are developed from the top down, where somebody says, okay, we're going to set out to create standards for this group that we're in charge of. These were more bottom up. It was a self-selected group that decided to take this on. Our plan is to put them up on a web page pretty soon, once they're kind of fully fleshed out, where they can live and be available to people, and hopefully maybe still continue to evolve over time. We're also planning to write a book coming up pretty soon. And the other thing that was really nice to notice is that this ended up being really great professional development for the people who are doing it. So, if you have some problem that needs addressing like this, I think it's really nice to convene a group of interested parties and just work together on writing some, kind of making some kind of artifact to share with other people. It wasn't, the original goal wasn't professional development, but it really ended up working out that way pretty well. I'm going to skip through these because we don't have much time. People have said things like, this project has challenged me to reconceptualize my GeT course. It's impossible to work on this project and not reassess one's own teaching of geometry. My participation in this community has challenged me to broaden my approach to teaching geometry. Prior to my involvement in my 20+ years of teaching the GeT course at my institution, I'd become settled in my view of how the course should be taught, or at least how I could best teach it. But my participation in this community has compelled me to reconsider that belief. I would just encourage people to think about this as a possible approach to professional development. And so I'll stop there, and if there are questions, I'd be happy to answer them.
All right. Thank you so much, Nathaniel, for sharing that information. The next session will be at 1 o'clock, the last plenary talk and closing remarks. I will paste into the chat right now the link for that. It will be, this meeting room is going to close. Let's see. And it does look like there was a comment actually that your remarks would be good to share in a journal, and there's a link there, Nathaniel, if you'll check out the chat. Otherwise, I have included the links for the next session, the next closing talk. And while you're accessing those are also available through the conference website. And when you're at the conference website, don't forget to swing by the virtual booth to say hello to the Hawks team. There you can view a 5-minute demonstration and be entered to win a $50 Amazon gift card. Thank you for your time, and we will see you at the next session.
Thanks, everyone.